We've already looked a little bit at graphing exponential functions in the aspect that we've looked at the general shape, and we looked and saw that there was exponential growth and exponential decay. And we saw that exponential growth looked something like this, where we start down low and our function increases fairly rapidly. And when we looked at exponential decay, we talked about how we start with large values and we increase down towards our low values. Noticing on both, we have that horizontal asymptote, meaning we approach the y-axis, but we never actually, we approach the x-axis, but we never actually touch it. So if I put in some more specifics, when I'm talking about the domain, so my x values of my exponential growth function, I notice that it looks like I'm taking all my x values all the way down to negative infinity. And as this function kind of continues to grow, I'm going to continue to use bigger and bigger x values, making me think that my domain, or showing that my domain, is going to go from negative infinity up to positive infinity. My range, on the other hand, notice is going to include extremely large y values, because again, range refers to the y values. But as far as the negative y values go, I'm never going to get down there. In fact, I'm going to get super, super close to 0, but I'm never going to touch it. But I can get as close as I want. So I could have 0.01, 0.001, 0.000001. So to show that I'm getting as close as possible to 0 without ever actually being 0, I'm going to use a parenthesis instead of a bracket and say that my range or my y values go from 0 all the way up to infinity. I mentioned just a moment ago there's an asymptote. There's a horizontal asymptote. So I'm going to say there's a HA to stand for horizontal asymptote. You may want to write it out in yours. But my horizontal asymptote is where I'm approaching that x-axis. Well, what equation represents this x-axis here? Well, doesn't every single point on that line have a y value of 0? So I'm going to go ahead and say that I have a horizontal asymptote at the line y equals 0. Remember, my x-axis, x-intercept is where I cross the x-axis, but since I never actually cross or touch the x-axis, I'm going to go ahead and say there is no x-intercept. And my y-intercept, remember, I find that by plugging 0 in for x. So when I plug 0 in for x, I have f of x, or y, equals b to the 0. Well, even though I don't know what my b is, I do know that anything raised to the 0 power, think back to algebra, anything raised to the 0 power is just 1. So I'm going to go ahead and say my y-intercept is going to be 0, 1. If I do the same thing for exponential decay, notice my domain is the same. So I'm still going from negative infinity to infinity, because if I were to continue this on, I would continue to use more and more negative x values. My range, once again, is going to include all those large y values, but I'm not going to include any negative y values. In fact, I'm going to get closer and closer to 0. So again, I'm going to start at 0 but not include it by using a parenthesis as opposed to a bracket and go up to infinity. Again, I have a horizontal asymptote on the x-axis, which we know is the line y equals 0, which once again means I have no x-intercepts. And notice that, as I had pointed out here, it didn't matter what my b is. It could be any number. It could be a number greater than 1, or a number between 0 and 1. Either way, when I raise it to the 0 power, I still get 1. So I'm still going to have that same y-intercept of 0, 1. When we graph exponential functions, oftentimes we're going to have... So I just had to pause the video, so there's probably going to be a break. I don't remember where I left off, but where I want to move from here is looking at how we're going to use our shifting and our translation rules to look at functions that aren't just in the form f of x equals bx, but in the form f of x equals 2 times bx, or 2 times bx minus 4. So let's go ahead and jump down to those. And we're going to graph 4 different ones. So looking at the first one, I notice I don't have any translations going on. So I just look at my base. Because my base is greater than 1, I see it's going to be a growth. Depending on the size of your base, it's just going to depend on how quickly it grows. Bigger numbers are going to grow faster than smaller numbers when you look at your base. So I'm just going to go ahead and sketch a rough graph. I know that I want my y-intercept to be at 0, 1. I'm going to have a horizontal asymptote here. Oftentimes we use a dashed line for a horizontal asymptote. And I draw on my growth function. And to see how these all relate, I did make all of them growth functions and I did all of them base 4. Excuse me. Looking at the second one, I see I'm subtracting 2 inside of my exponent, so inside of my function, and adding to the outside. So I know that this is going to go right 2 and up 3. So I'm going to go ahead and say I would normally be right here. So I'm going to graph kind of, well, no, I'm not going to put it there. I'm going to move that point. I'm going to put it there in red. But because I'm going to go right 3, I'm going to use my different color to go right 1, 2, 3. And I'm going to go right 2. And I'm going to go up 3. 1, 2, 3. And so I'm going to go ahead and take this point. I'm going to shift it right 2 and up 1, 2, 3. And that's where my intercept moves to. That's where my point moves to. I'm also going to say my asymptote started here, my horizontal asymptote. But if that also shifts up 1, 2, 3, notice that it's now here. And I'm going to use that new point and that new asymptote as a guideline. I know it is growth. And if I had more room, I could show that going up more and continuing in that growth fashion. Looking at the third example, I see I have a negative out front. Well, I know that's going to reflect over the x-axis. And I also see I have an add 5 up top, so I see that's going to be inside of the exponent. So inside of my function is going to tell me to go left 5. So again, I would normally start here, and I would normally have a horizontal asymptote here. But because I'm going to reflect over the x-axis, my intercept is going to reflect to right here, and then I'm going to move left 5. So notice I'm not moving up or down at all, so my horizontal asymptote shouldn't change at all. But moving left 5, 1, 2, 3, 4, 5, I'm going to take that intercept, it moves left 5, and again, my asymptote doesn't move because I'm not moving up or down at all. It does because it reflected over, almost look like it's upside down from the growth, and there's going to be my new function with my translation. And then finally on number 4, again, I have a negative, but now it's inside of my function, so I know that that's going to reflect over the y-axis. So I'm going to say our y-axis just to shorten it up. I'm subtracting from the outside, so I'm also going to say I'm going to go down 2. So I would normally have a y-intercept right here. So notice reflecting over the y-axis isn't going to change that y-intercept. However, it is going to change from looking like a growth function to reflecting over to look like a decay function. I'm also going to have to go down 2. Remember, my horizontal asymptote is normally here at y equals 0. So when I go down 2, I'm going to have to shift both my intercept down 2 as well as my horizontal asymptote. So my intercept will shift down 2 here at -1 on the y-axis. My horizontal asymptote is now at the line y equals -2. And again, because remember it reflected over, it went from looking like a growth function to reflecting over to look like a decay function. So adding that graph in, here is going to be my new graph with my translations. So again, knowing my general shape and knowing both my intercept and my horizontal asymptote, and doing the same translations to that intercept and that asymptote is really going to help guide me when I draw in my new graph based on my same translation rules. So if you have any questions on this, please let me know, or if you need some assistance on coming up with those translation rules. I did not give them to you here because they have been given to you before. But like I said, if you need those, please bring that to me in class, and I can get that to you. And that's it for this video.